Okay. Hi guys, thank you for coming. My name is Mario Fusco. I work for Red Hat. I'm from Italy and I work mostly on the development of Quarkus core and more specifically on the LangChain4j project and the LangChain4j integration with Quarkus nowadays. Dimitrios?
Yeah, I'm Dimitrios, currently working on the evaluations part of LangChain4j, and not much else for me.
Okay. So we are speaking about everybody during this conference about generative AI, and we all know that generative AI is really amazing, or mostly amazing, sometimes not that much, but the problem is, this thing is wonderful, it's beautiful, it's amazing, but it can make mistake. So to me, the elephant in the room when I started using this stuff is, okay, but how I can test in a deterministic way something that work on a statistical basis and that can produce a different result at each and every iteration, right? And the problem, of course, comes from hallucination. And the fact is that there are research and there are people working on it, and data scientists. I'm not a data scientist. I try to integrate models, but people working on this stuff admit that there is no clear solution for hallucination. Hallucination are intrinsic, are a problem, not a problem in reality, are a behavior that are intrinsic in how this thing work, and there are papers, mathematical demonstration that this thing is not avoidable completely. So we need to deal with this, right? So, you know, there are a few different kind of hallucination that you could have. I mean, the reply can be inconsistent, or there could be an inconsistency between the requirement, the input provided by the user, and the output generated by the LLM. For instance, I can ask something. I can ask the LLM to reply in a very formal way, and the LLM replies your voice. Okay, this is clearly an hallucination. And then what is typical, even more typical, but also more problematic, is when they are factually wrong. I mean, when they made the fact out of the blue, because this is, in my opinion, another problem, right? To me, one of the main issue with this kind of tool is that they never say I don't know. Okay, they give you an answer whatever it is. Most of the time it's the right answer, but otherwise they make up. Okay, and okay. This hallucination can happen for a number of reasons, because you have partial or inconsistent training data, you are using wrong configuration, probably you give it too high temperature, so the LLM is free to be more creative than usual, and also the quality of the context of the input provided by the user could be better. And then this is the reason why we have these so-called prompt engineers that are able to talk better than us with this kind of tool, right? But in general, if you think about it, this hallucination problem introducing a kind of malfunctioning that is a little bit unprecedented in our work, okay? I mean, I'm a software engineer, I'm used to deal with a bug, so what is a bug? I wrote my code, and probably in an if condition I put an or instead of an and, then my code breaks, hopefully not in production, but it has a bug. I spend my night trying to debug in this thing, and I find the problem. The end should be an or. I fix it, I deploy it in production, and I'm done. But there's a malfunctioning, there's a bug, I can investigate it, and I can fix it. But what you do when you have a problem like an hallucination. What you do when you have something that is behaving in an unexpected way, but not because there is a bug that you can go and fix. It's because it is intrinsic behavior. It is how it works, okay? And you cannot completely remove hallucination. Yes, models are getting better and better. They accept larger contexts which help to reduce hallucination. Sometimes it makes the problem even bigger. But there is this problem, and we need to cope with it in a way or another. Okay, so there are typically a few kind of solutions. One of solution is that you use some programmatic way to parse the output and try to understand what's going wrong. And the other typical solution is that, okay, the idea is let's use an LLM to judge the work of the first LLM. This is another typical thing that we are doing nowadays. And to be honest, when I first heard about this pattern, okay, let's fix an LLM, let's control the output of an LLM with another LLM. This reminds me of a very old joke about XML. 20 years ago, we said that XML is like violence. If it doesn't work, it's just because you are not using enough of it. And I have the feeling that we are trying to apply the same pattern to LLM nowadays. But in reality, this is a pattern. So it's called actually LLM-as-a-judge, and you can use this pattern together with some more programmatic and statistically based approach. So what I'm saying is that this thing is not entirely deterministic, and we have to to cope with this problem and do something about it. Also, the way we test and we evaluate our software has to be different, okay? And the problem is also in how the reason why we write tests, the reason why we want to test our application. To me is that if I have a red test, it doesn't mean that, well, it means that, that there is something to be fixed, but it's not the reason why I wrote the test. The reason why I wrote the test is that I want to be confident that I don't have evident bug in my application, and I want to be confident in releasing it. And I want to be confident in refactoring it, okay? Because if I do a refactor, if I change something, I want to be confident that I'm not breaking anything. So this is the reason why I write test. So, and again, I was speaking about refactoring and stuff like this. So that's the real, the goal of test, the purpose of test. Yes, I want to prevent breaking production. That's true. But there is something before. I will break production is if I do some change in my code and I don't have a test to tell me, don't put this thing in production. Again, I want to write tests to be confident that the things that I'm doing, it's good enough. And that's why we are testing application. Like we want to make sure that the code matches our intention, and we want to create a selected set of usage for our software and make sure that given a certain type of input, we will receive the expected output. And again, things are a little bit different with AI-infused application because this is not entirely doable in this way. I mean, it's not 100% said that I do something and it produces the result that I expect, and the very time after, I will do exactly the same thing, but I will not receive a different result. So we need to approach test and evaluation of this system in a little bit different way. Okay, so I said that I'm one of the contributors of LangChain4j. So I had I was working on something totally different or not related, even related with images, but I sent this pull request to LangChain4j, and the test didn't pass because of this test, okay? Which is totally related with what I was doing. And what happened here is that, okay, I have this test, and this test loaded that cat image and sent the image to the model. And the assertion is, okay, I expect that the description of the model, I'm asking to the model, what do you see in this image? What do you see? Okay, this is what I'm asking to the model. And my assertion is that, okay, I expect that whatever the response is, there will be the word cat in it. Okay, not a so strange requirement, okay? And then the test break up because I had this failure. And because this time the response of the model was, I see an animal with a failing appearance, okay? And of course, the word cat is not there, and the test failed, okay? So this is to say that test fails in very unexpected way. So I just wanted to show you here an approach of how you can test this stuff. I have this other application which was that was an example that I was doing to test one pattern of agentic AI. So what I have here is that in this application I have that Ruder agent that is a first LLM that decides the category of the user question. So it decided if it is a legal or medical or a technical question, and then it forward the response to another LLM that is specialized for that topic. Okay, this is what it does. So this is the code, and then I wanted to test this thing. Okay, so if you want to test this thing, this testing framework at the moment is available in the Quarkus extension, but for this feature and other features like guardrails, for instance, we are slowly porting our features from the Quarkus extension and make them available also in vanilla LangChain4j. But in essence, how do you test this stuff? You import this test scorer JUnit extension, and then you have this scorer utility that is injected inside your test, and this allows you to test your LLM in a statistical way. Okay, so you create a few samples. You can have these samples in a JSON file, or you can write them programmatically as I did here. So I have a sample to say that I call the LLM with the sentence, I broke my leg, what should I do? And then in this case, I expect that the output is that this is a medical topic, so the question should be rerouted to the medical expert. And I do the same for a second sample with a legal question, okay? So I create this set of sample. I evaluate this sample against a function, and I can use a few evaluation strategy, and an evaluation strategy is just a predicate that says if the evaluation is has been successful or not. And at the end of the day, you say, okay, I will have a score of all this evaluation. In this case, I'm expecting that I expect the full success, they all success, but what you typically do is that, okay, I'm fine if the 80% of these samples will produce the result that I expect. So this is how you test this stuff, okay? And out of the box, our Quarkus extension provides a few utility evaluation strategies, and these are the most important part, okay? So again, the most important thing is that how I evaluate that the output of the LLM is valid, okay? Because otherwise I will end up with this problem, with this naive approach, okay? My evaluation in this case, I want to fail if the response of the LLM doesn't contain the word cat. But it fails, and if you think about it, the response of the LLM wasn't wrong. It says, I see an animal with a failing appearance. So the response was okay. The response was valid. But it was naive for me in this test to test if the LLM is behaving correctly or not, simply because if its response contains the word cat or not. Okay, so again, we want to evaluate our test in a little bit different way. So this is why we introduced these evaluation strategies within the Quarkus test extensions. For instance, you have a semantic similarity strategy. What this thing is doing is taking the response, the actual LLM response and the expecting response, and vectorize the two responses, create an embedding model of the two, and assert that the cosine distance between these two responses is below a given threshold. This is something that you can typically do. Or, for instance, this is another example, but if you go in the project, there are a few of these evaluation strategies. There is, you can do the LLM-as-a-judge pattern, so you can say, okay, you evaluate this response using this another LLM that is supposed to say, okay, the response is fine or not. So this is my approach to testing this stuff. And with this, I will leave the...
So, yeah. So, as we saw, there are problems in evaluating LLMs this way. So, what we are trying to do here is bring a way to evaluate stuff within LangChain4j. First of all, I think maybe it has been repeated a few times, but do we know what RAG is? Okay. It stands for Retrieval Augmented Generation. That's what we focused on for now. It allows an LLM to gain a bit more context when it's asked something. And what we are trying to evaluate really in this case is the retrieval. So what the store or the system that you have set up returns to the LLM, and the generation of the LLM itself, the answer that it gives back. So we had an issue in our case. We have an application that helps with the documentation when a user has a question. So this is the application at chat.langchain4j.dev. And you know, we've set it up, but we wanted to see whether we could improve on it. So we needed to set up an evaluation for it. Really, there are three things here that we want. First of all, we needed, after setting up a scope for it, a dataset. So a set of scenarios that it's a set of scenarios that we want to see how the LLM reacts to and see where it differs from them. So going on to make one, really the steps here that you want to follow is first of all, see what you want to actually evaluate in your application. Maybe you want to see how chunk sizes change its performance, or you want to use different models for it. And at this point, you will find what data you need to actually gather from your application in order to make entries, and at this point, you can go to the real world and actually try and find dataset entries that you want to use, or there are also ways to generate some entries synthetically. In general, you want to have a dataset that has a lot of them, a lot of entries, maybe 100 or more. But it's important here to note that you don't want it to get unwieldy. So, you can easily download it from an S3 bucket or move it around. So, in our case, we have that application. We took logs from it, traces, and we started going through them and gathering the parts where it was giving context, the parts where it was giving an answer, and the queries. And after going through a lot of them, we ended up with pretty much a data set. So to show it a bit more practically, we start from the application where we asked it a lot of questions. We went on to the logs that, okay, they're a bit chaotic currently, but after a bit of cleaning, we came up with entries pretty much like this one. Since we want to check retrieval and generation here, we gathered the context that our LLM was being given and its answer along with the question that was given at the start. So
the point is here also, as Dimitrios was saying, is also that in this context, have curated the data, have garnered the data, as Dimitrios said, is sometimes even more important than having a lot of them. Okay, yes, this thing needs a lot of data to work, but it has to be data with good quality, and you have to do some work to clean up them.
Obviously, yeah, that's the most important part, and we also say this at the end, but you need to make sure that the entries actually represent what you want to test, and they actually give results that you would want to get from your application. So, I mentioned before that there is also a way to generate synthetically data. We tried it. At least currently, it is a good way to get more entries in a lower cost and maybe even cover stuff that your documentation might not be having. At least for now, I wouldn't suggest specifically relying only on it, but it's a good way, I guess, for now to mix the two methods, both actually having your own entries and add stuff synthetically to help a bit with the evaluation.
Yeah, another thing, sorry, to notice there is that the handpicked data, the curated data, are more likely to reflect real-world situation. This is another thing that you should care about, because with synthetic data, the data, becomes redundant or irrelevant, or they contain something that you really don't want to be there. So for now, yes, as Dimitrios said, probably the handpicked.
Maybe, yeah, the models that actually generate synthetic data are evolving. So probably it might become a better option later on, but for now, at least, I'd say it's good to supplement your existing dataset. So we have our data. Now we need some way to score them, run the application. Running the application will get some entries from it, and we need to say, okay, how good or how bad is it? And for retrieval, you might say that, it's just text, and there's no special generation on it, so it shouldn't really match. So we could just go with string matching everything. But as Mario said before, this starts to become problematic. I mean, first issue here would be, you have an entry from your dataset. So in this case, you have 2 paragraphs. And because you change the way your store chunks the text, the entry gets returned, but in 2 pieces. Easy? you might say. You can just string match it here, but what happens here? You're missing half the paragraph. Did you pass it as, OK, we found what we needed, or do you not? And it gets even more complicated from here. What if you have it, you break it down even more, you have sentences of it. And even on the generation side, where there is, it's even harder here, because as we said before, you can get a completely different text that says the same thing.
So this is essentially on steroids, the same problem that I was mentioning before, but even in a more complicated way. The problem is, how do I decide if the produced result is good enough? Is the result that I expected enough? That's the main problem that we need to address with this thing. Again, saying the output contains the word cat is not enough.
It needs a bit more magic to make it work. So that's what we are bringing to the table currently. We have some scorers or evaluators, whatever you want to call them, for document retrieval and document generation. The generation part is currently under development, but yeah, for the document retrieval, we have simpler tactics to get the similarity of text, like sentence level precision and recall, or even token level matching. But we also have more complicated algorithms for them, like Resumé or fuzzy text. So we have our scorers. You can pick one of them. You have our data. We can actually make a little program that evaluates our application. The steps of the program are pretty much these ones. So you set up what you want to evaluate from the application, or the whole application, at least whatever you can. So in our case, we are setting only a store for it. You determine what you want to change in the application and track how it changes. So in our case, we could try to see what changing the size of chunks or the overlap of the chunk, how it affects our application, or even change the number of entries that we get from the dataset, from our store. Having said that, you can run through all the entries and each time get a response from your application, grade it with the scorer, and at the end, average your result. So having done that, you change the parameter that you are tracking and go again and again and again and again for as long as you want. So we can start the demo here to show it to you.
Maybe you want to explain. Yes, I will start it, but
yes.
You want to explain what's happening here while it runs.
So, as I said, we have set up the store part of the application. The first lines are where we load the documents, split them, calculate their embeddings, and add them to the store. After that, we are setting up, let's go a bit lower. Here, yeah. After that, we set up our scorer. In this case, we are using fuzzy matching for the chunks. And
maybe
also,
you want to say how this thing works?
Yeah, pretty much.
Because again, this is say the usual problem. We need to evaluate what's going on here, right?
Yeah.
So.
Sure. So in this case, we want to calculate the precision and recall for a set of given chunks of text. So in this case, we are having like 5 chunks from our dataset and 5 chunks from whatever application we have set up. And we want to see here for precision how many of the chunks that we got from the application are actually relevant. And for recall, we want to see of the chunks of text that we have in the dataset, how many of them were actually found in the given context. So really here, precision helps you see whether you are starting to have entries that don't make sense. And recall at least helps you see that what you want to see, so what is in your dataset, is actually getting found from the store. So,
Okay, so
going back to the...
yes, so this is to evaluate again. This is to decide how to evaluate a given sample.
Exactly. So, going there, we are setting up our evaluator. We also set a place to store the average each time. And then on the next part, we're going on to go through every entry and, as we said, get something from our application, evaluate it to get a score, and store it. So after everything, we've gone at the end, and we are showing our average. And we can show the terminal output. So that's our first result.
And yes, and it's pretty bad if you read the the numbers. So it's just a little bit more than the 7%, right?
Yeah, it's 7%.
Maybe you want to change this.
If we try and get maybe
again,
more content,
the effort here is that you play with this parameter. You try to figure out what's the best way to chunk to separate in chunk your input. Maybe you can play also a bit with the overlap size if you want to explain what it is more importantly.
Maybe we could change the number of results, like...
okay, but you see, there's a quite dramatic difference. Before I had, but for both precision and recall, 7% score, and now I'm 83 or 85% here. So it totally changed the way how it works by just changing the number of chunk, how the document is split.
Yeah, and we could even maybe try, let's try getting a few more results out of it, so like 10. So at this point, with the chunk size given, we saw that the result was already pretty high, so pretty much we are reaching a happy state where most of the dataset entries are found, or at least the content of them are found. In this case, though, we are asking it to get more content out of the store. So at this point, we'll see that precision starts to drop, and recall is getting higher.
Of course, yes.
Because we are getting what we want from the dataset, but at the same time, since now we have double the entries, we are also starting to get parts of content that they don't match what we expect. So precision drops.
So we are speaking about precision and recall probably.
Yes.
You can clarify what this means.
Yeah. Maybe it would help to have that slide from before where we explained it.
Yeah, sure. But in essence, so we are measuring these two
we
percentage.
Are trying to see, as I said before, for precision, we're trying to see whether we're getting any noise in our results, whether we are getting unexpected, or at least how much of the given answer in general is actually relevant. And for recall, we are seeing how many parts of what we expect to get are actually there. If you're starting to make an application with RAG currently, it would help, if you don't know where to go with, it would help starting with a call, because this would be the metric that shows you that you are getting what you expect. But after a while, it's important to also look for precision, because your context size for now might be constrained, so you don't want to get entries that shouldn't be there.
So of course this is the reason why we got this latest result. Dimitrios increased the number of results that we got from 5 to 10, and then we are getting more results. So we are getting more of the result that we wanted to retrieve. So the recall is going up. But of course, since we are getting more of them could be not relevant. So the precision is going down. And you want to find a good compromise between the two, right?
Yeah, you need to find a balance between the two. So, yeah, we could, this is after running a few iterations, changing the parameters, what we can get, we are seeing pretty much what we expect. For example, on the first diagram on this side, we are seeing that, with a few entries, whether when everything is where it needs to be, we are getting a high precision because most of them are correct, but we are not getting all of the content that we expect. So recall is lower, and as we add it, they reach a point where they are in a happy balance, both of them at 5, and going further, we see that recall is increasing, but doesn't look that much like it because it's not much, but precision starts to drop. A similar situation happens on the other two. Changing the size of the chunks gives you more chunks to actually find things. So
up to a certain point.
Up to a certain point, yeah, we reach a point where we match what we want, but adding more of it also starts to add noise to your content. And the last one was actually we wanted to see if we changed the embedding model for our store, how it would affect the application. And yeah, changing the model changed the chunks significantly. So we see that the other models are struggling a bit to catch up. So some final thoughts, I guess, from this whole presentation, at least from my evaluation part. As we said at the start, garbage in, garbage out. You'll start hearing a lot more it from the data science crowd. So the evaluation is only as good as the entries that you have gathered. That's what we are taking against, and problematic entries will obviously cause problems. 100%ing a metric, like you might say we want 100% recall, might not be possible because it's hard to actually, we're trying to get the context. So the context might not be 100% similar, or not all of the entries will always be the same. You need to pick what you want to focus on your application each time, because you might say that, okay, we need to change both the chunks and the number of texts and overlap and everything, and changing them all together. Whether you want to really see the impact of each change. So it's good to separate the changes as much as possible in order to be better able to see how they affect your application. Sometimes some pairs might negatively work between them, as we saw for precision and recall. So yeah, that's expected. Maximizing for one, as we said before, can sometimes negatively affect your application. And the most important part at this point, the dataset is not set in stone. Your application will change as the time goes by. Your documentation could change in a RAG environment. So you need to update the entries when the code changes, or even in the future, you might find some better entries that you want to add. So it will always be changing to meet your new needs.
Okay, and my final thought on this, but this is also from where I started. the other important thing is choosing the right way to evaluate this output. Okay, you cannot say anymore, assert that this is the result that I will get for sure. It's a statistic algorithm, and it has to be approached with a statistical testing. There's no way out. Okay, and we added some the code that it's that Dimitrios wrote and commented. It's in the slides. If you want to get to see them, so you can.
If you want to get a bit more context
yes.
on what is going on, but I think we covered it pretty well.
Okay. And of course, here we are leaving you some references. So the very first entry is this evaluation project that Dimitrios showed, and on which we are still working. There are a few interesting readings on this topic, because it's quite a hot topic, in my opinion. There are a few interesting readings that we are still experimenting a lot, because the other thing that you notice is that it's real a trial and an error process. Okay, it's not written in stone. There are a few simple golden rules, but in reality, what you do is try different approaches. It's the same thing that you do probably with prompt engineering, right? You try different prompts, you try different approaches until you don't find something that works for you. And this is what we have. Thank you. Okay, we have a couple of minutes for question if you want, and otherwise we are around for the rest of the 3 days of the conference, so feel free to get in touch with us. Thank you.
Okay. Hello, thank you for your presentation. I have a question for you.
Yeah, sorry.
Can you go back, please, to the previous slide?
Which one?
Just the previous one.
This?
No, the one before.
The precision one.
Yeah.
This, the results?
Yeah, on the histogram on the top right. So here we can see that the recall is decreasing even if we, after we increase the chunk size. At a certain level, the recall decreased when it goes to 1,200.
Yeah.
So can you please explain
what happened here? Yeah.
Because theoretically, if we increase the chunk size to the the document, let's suppose that we have one document. If we increase the chunk size to the maximum size that includes the whole document, we should have the maximum recall. Should not decrease.
Maybe the scorer was a bit off here at this point. Not sure.
Sorry for the question.
Well,
it's an interesting question, and yes, so sometimes you even don't know. But yeah, probably one of the problem was that we are not using the right scorer for anymore at that point.
Most probably it's an issue with the scorer in this case, because it's checking for the chunks that are given. So the chunks are bigger in this case, but not fully match what we are expecting. So that could be why we are getting a lower recall.
Okay, thank you.
Thanks. Yes? Okay, thank you.
Yeah, thank you. Thank you for the presentation. I have one question is about the LLM. We use ChatGPT, right? So my question: did you switch another LLM and get the same result? Did you test several LLMs for precision?
First of all, we didn't use an LLM in this case. We are taking the retrieval. So we changed the embedding model that we are using. No,
We are testing, just to be clear, what we are testing here.
Maybe go to the code where we
yeah.
set up the store to better
When
show
you evaluate a reg, we are testing this,
this. Yeah. So,
not this. So we are not using an LLM at this stage. We are not generating content out of the retrieved content.
Yeah,
we are just testing if the retrieved content is relevant or not.
Yeah, we didn't interact with an LLM in this case. That would be the generation portion of the evaluation. We interacted only with the store of the application. So what chunks we get out of it. In this case, if you are looking for a model, we're using an embedding model, not a large language model. Yeah, and that's what we change on the final graph.
Anyway, in that eval project, there is also a second demo that
we
does
have
the
a generation
if you
demo,
want to try.
which currently shows what we've made up to now. But yeah, you can try it if you want.
Okay, we are out of time, sorry, but we are around. Feel free to get in touch. Thank you.